Today we're taking a look at section 8.1 on the rectangular coordinate system and circles. And we have a lot of vocabulary to learn initially. We will begin by looking at the rectangular or Cartesian coordinate system and fill in the labels in the coordinate axes that we're going to draw below. And I'm hoping the sound will be better on this recording. I know the last two or three, the sound has not been good, and I was having trouble with my headset. So I'm trying this without the headset. I'm using just the microphone to my computer. So we'll see how this goes. Okay, so we have an x-axis, which is horizontal, and a y-axis, which is vertical. And these two axes are perpendicular, and they meet at a point that's called the origin. It has coordinate 0, 0, and it's called the origin. And from the origin, we count, this would be 1, 2, 3, 4, 5, 6, 7, and so forth. In the negative direction, we also count. Okay, positives are up on the y-axis, and we count negatively as we go down. So -1, -2, -3, -4, and -5. Okay, now the two coordinate axes divide the plane into four regions called quadrants. So when we start numbering, we start with quadrant 1 is in the upper right corner. Then we go to 2, 3, and finally 4. Now the points that we graph on these are called ordered pairs. They are ordered pairs because the x, which is the horizontal move, comes first. The y, which is the vertical move, comes second. So if you're graphing, for example, the point 5, 2, you start at the origin, count 5 points to the right, 2 points up, and that is the point 5, 2. Let's do another one. Let's do -3, -5. You start at the origin. You go 3 units to the left, 2, 4, 5 down, and that's the point -3, -5. Okay, and let's do one last one. -1, 6. You would start at the origin, go 1 to the left, and then up 6. And that's the point -1, 6. So that's how we graph the points. Hopefully all of this is a review. You should have learned this in Algebra 1. Now, the next thing we do is we use what we call the distance formula. This is a way to find the distance between 2 points. It is based on the Pythagorean theorem and the fact that we can take 2 points on the coordinate plane and try to figure out the distance between them by using the right triangle and the Pythagorean theorem. So I'm going to go back up here and fix my graph so that I have the point 3, 9 and -1, 5. So I'm going to do a little erasing here to get rid of some of the extra stuff. Get rid of that point if I can. Whoops, I erased my 6. Okay. Let's take this off. I can take that off too. So then we can kind of see where the formula is coming from. I think if we do this one example with the graph, we can see where the formula is derived without actually going into the nitty-gritty of the algebra that's needed to derive it. So I'm going to use the point 3, 9. Okay. Let's see, get my pen back. 6, 7, 8, 9. So 3, 9 will be over here. And my other point is -1, 5. -1, 5. Okay, and what we want to know is the length of the distance between them. Well, notice we can construct a right triangle. If I drop down from the point 3,9 and move to the right from point -1, 5, I have a right angle here, and I can actually count 1, 2, 3, 4. This is 4 units. This one's 1, 2, 3, 4 as well. Okay, so what I want to do is I want to figure out the length of this here. Well, I know from the Pythagorean theorem, if I take the squares of the two shorter sides and add them, I'm going to call that d for distance. I'm going to get 16 plus 16 equals d squared. 32 equals d squared. So d is actually going to be, let's see, that's 16 times 2. It's going to be 4. We take the square root of both sides. 4 times the square root of 2. Now, if we think about the numbers that we have here in the coordinates, notice what's happening. This point right here is the point 3, 5. So the way we're finding this 4 is we're subtracting 9 minus 5. The way we're finding the 4 here is taking 3 minus a -1, and we end up with 4. Now notice sometimes if you, suppose you did it backwards and you said 5 minus 9. 5 minus 9 would be a -4. And if you did -1 minus 3, you get a -4. Well, what happens in the formula is that we square those differences, so that gets rid of the negative. Doesn't matter whether our difference between our x's is positive or negative, and the same for the y's. When we square that, it eliminates the negative and the positive anyway, and both of them will become positive. And notice within the formula we actually came up with -4 plus -4 squared, and then we took the square root of that. So we got the same answer by drawing it on the graph and looking at it that we actually did using the formula. So our formula is that we want to take the square root of the distance between the x, or the difference between the x's squared, plus the difference between the y's squared. And basically what we're doing is we're applying the Pythagorean theorem like we did here, and then taking the square root of both sides to get d. Okay, so first problem for you to attempt is to find the distance between -2, 7 and 3, 5. What I'd like for you to do is pause the recording and go ahead and figure out your answer. Once you have set your answer, then restart it so you can check your work. Okay, I'm assuming that you have found an answer for number 1. So we want the difference between the x's. Doesn't matter which one of these we start with. If you want, you can label this x1, y1, x2, y2, and go that way. And so x2 minus x1, so it's minus a negative, would be plus. Y2 minus y1. So we have the square root of 5 squared would be 25, and 3 minus 7 would be -2. Square would be a 4, so we have the square root of 29, and we can't simplify that any further. Okay, now the midpoint formula, basically what we do is we take the average of the points. So in other words, we're going to add the x coordinates and divide by 2, add the y coordinates and divide by 2, and that gives us our midpoint. So -2 plus 5 divided by 2, 8 plus 10 divided by 2, we get 3 halves and 18 halves, and we can reduce 18/2 to 9. So we come up with our midpoint there. Okay, so again, pause the recording and see if you can find the midpoint of the line segment -7, -2, and 3, -8, the line segment formed by those two endpoints. All right, so I'm assuming at this point you've come up with an answer. So here's, plug it into the formula, -2 plus -8 divided by 2. So -7 is going to be a -4 over 2. That's going to be a -10 over 2. And that's going to give us a -2, -5. Okay, now the last thing we have from this section is the equation of a circle. It says the equation of the circle of radius r and with center at hk is x minus h squared plus y minus k squared equals r squared. In particular, a circle of radius r with center at the origin has the equation x squared plus y squared equals r squared. Okay, so find the center and radius of the circle having the equation x squared plus y squared equals 36. The center would be at the origin because we don't see anything being subtracted from x or y, and the radius is the square root of 36, which would be 6. Okay, so think for a moment. We're just going to pause briefly here. What would be the center and the radius of the equation in number 3? X squared plus y squared equals 100. Okay, good. The center again would be at the origin, and the radius would be the square root of 100, which is 10. Okay, suppose we're asked to find the center and radius of the circle having the equation x minus 4 squared plus y plus 9 squared equals 49. The center, remember the format of the formula is x minus h and y minus k. So x minus 4, that means h is 4. Notice what we have to think here. It has to be minus a -9 for us to get a plus there. So the k coordinate is -9. Radius is the square root of 49, which would give us the 7. Okay, so see if you can figure out what the coordinates of the center and the radius would be in number 4. Okay, I'm hoping you've figured out that the center would be -1, 7, and the radius would be 2. And I believe that's it. Okay, your next step will be to do the to watch the sample problems.